All right. Okay. So here's the plan for my second lecture. We're going to take our starting point to be this basic observation that we discussed at length in the last lecture, that nature is full of regularities. So bread nourishes, planets have elliptical orbits, quantum systems evolve in accordance with the Schrodinger equation. Now, the big question that we're going to focus on in this lecture is, why does nature exhibit these regularities? Like, why should it have been this? Why should the world have been such that there are any regularities at all, let alone the ones that we actually have? Now, here's the proposed answer. I'm going to sketch an argument that God provides the best explanation of this remarkable fact about our world. And then at the end, I'll consider some practical lessons. So specifically, I'll suggest some lessons for how we think about the relationship between theistic religion and science. So there's the really broad roadmap of where we're going to go in this talk. Okay, so to begin, let's consider a toy example. So imagine that you're playing a game of poker with your friend Al. So poker is this game where you try to win by having a hand of cards that's better than other potential hands. Now, Al deals himself a sequence of 5 consecutive royal flushes. A royal flush is just the name of a hand. It's the best possible hand in this game, and it's also an extremely rare hand. The probability of getting this on any given hand of cards varies depending on the specific type of poker that you're playing, but in many popular versions, the probability is somewhere in the vicinity of 1 in 30,000. So to receive 5 such hands in a row would be pretty remarkable. So you consider the following 2 hypotheses. First, the cards were dealt from fairly shuffled decks. Second, Al manipulated the decks. So the question arises, which hypothesis do you prefer and why? If you're like me, even if you didn't start by thinking that Al was a cheater, like if you thought Al seems like a nice guy, the sort of person I would happily play games with, after observing this sequence of hands, you'll probably be convinced that something funny is going on. Now, why do we think this? Well, in general, you might say, look, what we're doing here is balancing different explanatory virtues. So one virtue of a hypothesis is just that it's sort of plausible to begin with. So you might think that if we weigh the fair hypothesis and the cheating hypothesis against one another prior to observing anything at all, we might be inclined to think that fair play, like the fair hypothesis, is probably more probable. After all, fair play it happens a lot more than competent cheating does. But there's another sort of explanatory virtue which concerns how well a hypothesis makes sense of an observation. Given the fair hypothesis, this sequence of 5 straight flushes in a row is really surprising. But dealing yourself the best possible hand seems like the sort of thing that a cheater might do. So the cheating hypothesis makes better sense of the observation. And so what we have to do is weigh these different explanatory virtues against one another. And in this case, it feels like the cheating hypothesis comes out on top. Now, if we want to make this more precise, we can do so using a little bit of math. So the equation that you see on your screen is what's known as the odds form of Bayes' theorem. At rock bottom, it's really simple. It's basically saying, like, a way of formalizing those 2 different explanatory virtues I just mentioned and describing their relationships to one another. So if we start on the very right-hand side, you'll see there's a ratio. The probability of hypothesis 1 over the probability of hypothesis 2. These are called prior probabilities, and the ratio between them just expresses how plausible we think hypothesis 1 and hypothesis 2 are prior to observing something. Okay, the term O just stands for the observation, so something we've observed. So this ratio in the middle, the probability of hypothesis 1 given the observation over the probability of I'm looking at the wrong thing on my slides. Let me start over. If we look at this middle term, the middle ratio, the probability of an observation given hypothesis 1, and the probability of an observation given hypothesis 2, that's what's known as the likelihood ratio. But basically what these probabilities are describing is how well a hypothesis makes sense of an observation. And so the theorem just says that these two explanatory virtues, the prior probability and likelihood, balance equally. They trade off. And what they determine is over here on the left. It's called the posterior ratio. This is how likely a hypothesis ought to be after the observation. So we could say that hypothesis 1 is a better explanation of an observation than hypothesis 2 whenever the probability of the first hypothesis given the thing you've observed is greater than the probability of the second hypothesis given the thing you've observed. So if we want to, we can then characterize our reasoning in the poker scenario much more precisely. For example, we can say this. Look, it may be that the prior probability of fair play is greater than the prior probability of cheating. So we'll grant that the probability of F is greater than the probability of C. However, the probability of observing this sequence of hands, given the cheating hypothesis, is vastly higher than the probability of observing this sequence of hands, given the fair hypothesis. So when we plug these two valuations into Bayes' theorem, we just do a tiny bit of algebra, and the result is that the probability of the cheating hypothesis given the sequence of hands is greater than the probability of the fair hypothesis given the sequence of hands. And thus we judge cheating to be the better hypothesis, the one that's more likely to be true. Finally, one last way of trying to make this intuitive. If we want to, we can represent the probabilities in visual terms. So suppose that the size of a region corresponds to its probability. So the fair hypothesis is represented by the dark gray region. So that's regions 3 plus 4. The cheating hypothesis is represented by the light gray regions, or regions 1 plus 2. So prior to observing anything, your confidence in the two hypotheses is given by the ratio between the dark gray region and the light gray region. Then what we do is we reason about the likelihoods. We say like, well, if I were to observe these 5 straight flushes in a row, how likely would that be given the fair play hypothesis? Well, in this case, it would be 1 over 30,000 raised to the 5th power, a very small number. So when we pick out a portion of that fair box that corresponds to observing the sequence, that's compatible with the observed sequence, it's going to be very small. So that's why region 4 in this diagram is very small. When we then ask about the likelihood of this observed sequence on the cheating hypothesis, we say, well, it does seem like the sort of thing that a cheater might do. Like a cheater is not going to arrange the decks so that they perfectly resemble a randomly shuffled deck. If they wanted to do that, they would just randomly shuffle the deck. So this kind of behavior, this kind of like pattern, regularity, full like observation is going to get a bigger portion of the cheating box because that's what cheaters do. So that's why region 2 is like occupies a much larger proportion of the light gray region. Now, what happens when we actually observe the sequence in question? What we have to do is just look at the region of our diagram in which that sequence obtains. And then what we can do is say, oh, well, look, region 2 is much larger than region 4. So if I don't know which region I'm in, except that I'm in the lined region, I'm more likely to be in region 2 than region 4, which means I'm more likely to be dealing with a cheater than with somebody who's just had a really lucky string of hands. Okay. So how does the nomological argument for the existence of God work? This is the name of the argument that's based on the idea that God is somehow responsible for the regularities we observe in nature. Well, as I noted at the very beginning, this argument begins with an empirical premise, namely that nature exhibits regularities. Now, the version I'm going to discuss today is slightly more specific than that. The notion of regularity here has this particular mathematical character. So to illustrate this, consider Newton's law of universal gravitation. So equation 2 here is just a simple statement of the law. On the left, we have the gravitational force. And then on the right, we have the mass of one object, the mass of another, their distance squared, and then the gravitational constant g. Now, all of the terms of this equation, except for the constant, describe precise quantities of physical properties. Well, this is a distinguishing feature of modern scientific theories. And it's interesting because it suggests that ultimately, the deepest, most interesting, most significant regularities we observe cannot be described adequately without using math. There's a kind of quantitative structure that has to be represented in our theories. And so it's a remarkable fact that our world exhibits this beautiful, elegant sort of structure. So that's the starting point. Now, there are two theories of laws that I'll mention at this point. More will come later. The first is just Humanism, which will be familiar from the last lecture. But in case you weren't all here, I'll quickly run through it. This is the view that the world is like a grand mosaic whose tiles could have been arranged any which way. Laws are merely a description of the most significant regularities that happen to occur, so they're nothing over and above the regularities. There is no genuine necessity that underlies the laws. Nothing is ultimately responsible for the patterns that we observe. They are just a basic, fundamental feature of our world. As you can see, this is sort of analogous to the chancy hypothesis. The other view is intended to be analogous to the cheating hypothesis. It's called divine voluntarism, and it's the view that there is an intelligent being, God, that has the power to intentionally control the distribution of events in our world. That is, God gets to determine whether there are regularities or not, and if so, which regularities are exhibited in nature. So we can then give an argument that is analogous to the argument we gave in the cheating example. Regularities in nature, this empirical premise of the nomological argument, are intended to be analogous to that sequence of great hands in the game of poker. Humanism is supposed to be analogous to the fair hypothesis, and divine voluntarism is analogous to the cheating hypothesis. So we can take that same figure as before, and then the logical structure of the argument is going to be represented in the same way. So you might say, look, we could start off by thinking that humanism is a bit more plausible than divine voluntarism, maybe because it posits fewer basic entities. But when we think about regularities, like, it might seem unlikely that humanism would give rise to the kinds of regularities we observe. There are just so many possible distributions of particular matters of fact. Why think that the ones we would get would be the ones that are so easily and I shouldn't say easily, so elegantly described in these precise mathematical terms? In contrast, if there were a God, creating a world with this structure seems like the sort of thing that an intelligent being might do. So the probability of regularities given divine voluntarism feels relatively high. So once we've observed regularities, we find ourselves in this lined region, and we see that a greater amount of the probability gets apportioned to divine voluntarism. Or if you want to use it, run the argument in terms of numbers, you can do so as follows. Grant that the prior probability of divine voluntarism is lower than that of humanism, just not by an utterly drastic amount. Second, the probability of regularities given divine voluntarism seems much higher than the probability of regularities given humanism. Once again, we do a little bit of algebra, and the result is that the probability of divine voluntarism given observed regularities is higher than the probability of humanism given observed regularities. So let me say a little bit more about why these premises, by which I mean premise 1 here and premise 2 here, are plausible, or might seem at least plausible initially. So concerning the prior probabilities, why might we think that the probability of humanism is higher than divine voluntarism, but not by much? Well, as I noted, Humanism is more parsimonious than divine voluntarism. Both views think that there is this mosaic out there with arrangements of events and qualities and so on and so forth. But divine voluntarism posits some extra stuff. So that might suggest that in some sense, divine voluntarism is a bit narrower. By making these bolder claims, it's possible, like, there are more opportunities to have things that conflict with the bolder extra claims. So in some sense, it's narrower, but not by much. One reason is that, like, when it comes to things like parsimony, like, we're doing metaphysics, and you might think that this is one of those sorts of considerations where, like, all things being equal, we should prefer theories that are simpler or theories that posit less. But it may not turn out that all things are equal. And when we think about the general overall structure of divine voluntarism compared to humanism, we see that both of them appear to be compatible with a huge range of phenomena. Like, upon learning either that there is a God or that there isn't a God, in both cases, we could see that a lot of our experience could be made to fit with either theory. This suggests that both are very general. In some sense, both are theoretically modest in that they're not making too large of a prediction about what specific kinds of things we might observe. Like, both humanism and divine voluntarism are compatible with the fact that my pen is blue right now. There's nothing about either theory that, like, has these arbitrary associations with particular matters of fact. Both are very general, wide, broad metaphysical theories. So that suggests that even if we do want to privilege one over the other, it shouldn't be by too much. They're just both broad, big picture worldviews. Okay, the other thing to note is that, well, because of the way the math works out, if it turns out that the likelihood ratio is really, like, there's a huge disparity, then you would have to argue, like, if you're going to worry about the priors, you'd have to argue that it's an equally large disparity here, and that just kind of seems implausible. Anyway, let's move forward. Okay, let's consider the likelihoods. So here's a general recap of how humanism works. It stipulates that the actuality of our world, as opposed to any other Humean world, is just a brute fact. So if you ask a Humean, why did we get this Humean mosaic instead of any of the other huge range of possibilities? The Humean's going to say, no reason, had to get one of them. But at the end of the day, there is no answer to the question, why is this the actual world as opposed to one of the other possible worlds? Moreover, Humanism is committed to a recombination principle of sorts. The idea is that if you want to start building Humean worlds, you got to start with some basic ingredients. So you've got some different ways of describing the structure of space-time, and then you've got different properties that can be instantiated at various points of space-time. And what Humanism is committed to is this principle that says any recombination of these properties with different points of space-time is a perfectly legitimate metaphysical possibility. So when you put these two features of Humanism together, the fact that which world we have is a brute fact, and the fact that it's got this recombination principle, you have the result that there's this vast array of Humean mosaics. Nothing should give us reason to assign a higher prior probability to one of them than any other. But also, pervasive regularities occur only in a very, very tiny proportion of Humean worlds. So the probability of observing regularities like the ones we observe, given Humanism, is very low. In contrast, when we consider divine voluntarism, we can think of lots of reasons why a powerful, intelligent being would prefer to create orderly worlds as opposed to ones with utterly miscellaneous distributions of particular matters of fact. Here are two quick examples. Certain moral or aesthetic properties can only be realized in orderly, regular worlds. And agents might well have preferences for worlds that have moral and aesthetic character. So if both of these things are true, we should think that the probability of regularity given divine voluntarism is much, much greater than the probability of regularity given humanism. And notice that this is so even if the probability of regularity given divine voluntarism is itself quite a small number. Because however small you think that is, like it seems like it's going to be much, much higher than the astronomically low value we've assigned to the probability of regularity given humanism. Okay. Given my initial lecture, though, most of you can probably already see what the central shortcoming of the argument I have just presented is. In the case of the poker example, we can't easily think of alternative hypotheses that would explain why Al received such a remarkable sequence of hands. But in the case of the nomological argument, there are other possible explanations. Notably, there are other versions of non-humanism about laws, some of which are very popular. So if we actually want to show that observed regularities constitute evidence for the existence of a God, rather than just evidence for the existence of some kind of primitive necessity or some brand of non-humanism, we actually need to look carefully at different versions of humanism and assess their strengths and weaknesses. So what I'm going to in the next two sections is look at two of the most popular versions of non-humanism in contemporary philosophy. I'll give an objection to each. This will allow us to understand some potential pitfalls of explanatory arguments in general. And then in the section that follows, I'll suggest that divine voluntarism avoids both of those pitfalls. Okay, so the first theory we're going to look at is called primitivism about laws. You'll recall that according to this view, laws are primitive entities in our ontology. So like God, they're posited to be distinct from the patterns of events in nature. And like God, they can impose structure in nature, but they aren't personal beings. They're just these primitive things, and there's nothing more to say about them beyond the fact that they exist independently of the regularities, but somehow govern them. So if you want to think about this, like if you're going to write down, like semantically, what's going on, like what does it mean to say that there's a law, it would look something like this. You'd say the locution, it is a law of nature, operates like it's just an operator that you get to stick in front of a sentence. So according to the theory, one thing you can do is write down a sentence, and then you stick this operator in front of it. And what that means in the context of the theory is that the sentence has to be a true sentence. Okay? The big picture worry, of course, when we're considering the nomological argument, is that primitivism might appear to have all the same explanatory virtues of divine voluntarism, yet it doesn't require a divine agent. Why might you think this? Well, suppose Newton's laws hold. A divine voluntarist can posit a God who decrees that Newton's laws hold, and that's how we explain why we observe the regularities we do. But a proponent of primitive laws can do exactly the same thing, just without talking about God. So what's wrong with this? Well, let's consider a twist on our toy example. So suppose that your poker game with Al is in fact a virtual game. It's taking place on a computer. Presumably, this won't do anything to affect your judgment that Al is cheating. But now imagine that Al tries to convince you to keep playing. He points out that the shuffling algorithm for this particular program is deterministic. I actually don't know. I think that now there might be some genuinely indeterministic shuffling algorithms, but if you want, you can imagine that they're playing on a 1980s era computer. And for a long time, there was this big challenge in computer science of how we could generate genuinely random numbers. So it's plausible that you could be playing on an algorithm that is purely deterministic. So Al says, look, we've got this deterministic shuffling algorithm. But that means that my sequence of hands was guaranteed to be produced by the algorithm. So you shouldn't be surprised that I received it. And you should be willing to keep playing with me. In other words, he's saying, look, because of determinism, the probability of me receiving this sequence, given the hypothesis that we've got a deterministic algorithm, is 1. Now, I'm guessing that you won't feel convinced. you won't want to continue playing. But why not? Well, here's one assessment of what might be going on. The claim that there's a deterministic algorithm is actually ambiguous. It could mean two things. One way of interpreting it is dA sub 1. Shuffling occurs by some deterministic algorithm. Another thing it might mean is that is represented by dA sub 2. Shuffling occurs by a deterministic algorithm that entails the specific sequence of hands that we observed. Now, when we think about probabilities, we can draw two conclusions. First, the probability that Al would get this sequence of hands, given the hypothesis that there's just some deterministic algorithm going on, is minuscule. There are a huge variety of different algorithms that could have been in play. Like, who knows which one it is? Why think that we would get one of the deterministic algorithms that produces the sequence? We wouldn't. Especially if we're supposed to be assuming that the algorithm is trying to approximate fair shuffling. But now consider the probability, the prior probability of dA sub 2, the other clarified version of the deterministic algorithm hypothesis. For exactly the same reasons, the prior probability of this hypothesis is extremely low. So the takeaway lesson here is that merely saying that the algorithm is deterministic does not explain why Al received this sequence of hands. So back to primitivism about laws. I think we actually can apply a similar lesson here. Appealing to primitive laws is analogous to Al's appeal to determinism. Why? Well, by hypothesis, primitive laws have no internal structure. There's no way of taking them apart, seeing how they work, and then making predictions about what kinds of sentences they're going to be like, or what kind of structure they're going to be imposing on nature. And for this reason, there's no reason to think that the it is a law that operator should be attached to a sentence describing irregularity, as opposed to literally any other sentence we could conceivably write down. Like, there's nothing about the structure of the theory that should make us think that laws have to be the kinds of things that give rise to regularities, as opposed to giving rise to irregularities or arbitrary Humean mosaics or what have you. So the result of this is that if we're simply told that there are some primitive laws, the probability of regularities given primitive laws turns out to be very, very low. On the other hand, if we stipulate that there are primitive laws that give rise to regularities, the prior probability of there being such laws, once again, turns out to be low, very low, just as low as the probability of regularity, given the general hypothesis that there are some primitive laws. What this means, in short, is that positing primitive laws appears just to push the explanatory problem back a level. The question, why do we have regularities, is a really hard question to answer. But so is the question, why do we have primitive laws that give rise to regularities? It doesn't seem that any advance has been made. So this gives rise to what my co-author, Tom Metcalf, and I call the peril of insufficient structure. Here's a way of summing it up. If you posit some laws, but you don't endow them with any sort of metaphysical structure, there's no reason to expect laws to give rise to regularities. Okay, so let's turn to a different sort of problem. We're going to consider a second theory. It's called dispositionalism. So this is the view that fundamental properties are powers. So the properties that are instantiated in nature have these dispositional essences, and this sort of gives rise to certain behavior. So for example, you might say, look, how do we make sense of gravity? Well, in virtue of being massive, you're just disposed to be attracted to other massive objects, where the force is determined by Newton's law of universal gravitation, or by the Einstein field equation or something. And that's what it is to have mass. So as these properties, as these dispositions interact with other things, as they encounter their stimulus conditions and then manifest, naturally regularities result. So in general, dispositionalism Dispositionalism says that regularities can be explained when they have a certain structure, namely, when the regularity describes the regular manifestation of a disposition. So because we have this additional metaphysical structure, the account looks a bit different than primitivism. It seems like regularities have to result. You're not going to get totally arbitrary Humean like mosaics coming out of a world when you start with some dispositional properties interacting with one another. So that seems like a good thing. But there's a downside. In the literature on laws and properties, we find a bunch of different arguments suggesting that an ontology of dispositions has a hard time explaining certain kinds of important regularities. So notably, regularities described by conservation laws, regularities described by functional laws and by retention laws. None of these seem to be regularities that just describe the regular manifestation of a disposition. So a conservation law talks about like a quantity of an entire system being preserved throughout all interactions. That doesn't seem to flow naturally or be analyzed in terms of like some object with a property being stimulated and then manifesting. They just seem like different sorts of claims. And with respect to functional laws, it's just hard to see how, like it seems like what we have are additional regularities being posited over and above the kinds of interactions that dispositions are capable of describing. Now, I'm not going to go into the details too much. I just wish to point out that the structure of dispositionalism says that we have a certain way of building necessity into a theory. And this restricts the kind of regularities that come out. That can be a good thing if we're worried about the peril of insufficient structure. But it has a downside. The specific metaphysical constraints on lawhood that are built into dispositionalism sometimes prevent laws from giving, or prevent dispositions from giving rise to the kinds of regularities that we observe in certain areas of modern science. So another way of cashing this out is to just say that this like mathematical structure that the laws are supposed to have turns out to be difficult for dispositionalists to accommodate. That's a slight oversimplification, but we can leave it at that for now. The rock bottom reason for this has to do with the way in which metaphysical structure is built into the primitive posits of a theory. So I do think that dispositionalists are correct to build more structure into their theories, but I worry that they've chosen the wrong kind of structure. Primitivists don't face this problem because primitivism about laws allows you to stick the "it is a law that" operator in front of any sentence you like. A dispositionalist can only stick the operator in front of sentences describing regular manifestations of dispositions, right? But the strengths of one theory end up being the weaknesses of the other, right? Primitivism falls prey to the peril of insufficient structure, and dispositionalism is susceptible to the peril of too much structure. So we have to find a theory that balances them. So Tom and I argue that divine voluntarism does strike the right sort of balance. So here's the argument in a nutshell. First, a couple of initial observations. Divine voluntarism has more structure than primitivism because it invokes the idea of God's power and God's will. So by invoking a personal being, there's something different than just a mindless primitive. Second, although divine voluntarism has more structure than primitivism, it invokes a different structure than dispositionalism. To see this, notice that any regularity that a scientist could posit is also conceivably the sort of regularity that a God could have decreed. So the big question then is whether there's any reasonable expectation that God would prefer to create worlds with regularities to creating worlds without regularities. And we think the answer to this question is yes. Why? Well, we'll give a two-step argument. Here's the first step. God might have certain higher order preferences. So preferences directed towards higher order emergent properties like moral and aesthetic properties, or like satisfying God's own interests, maybe even preferences concerning patterns or the contents of law statements themselves. Why do we say that God might have such preferences? Well, for starters, it just seems to follow from the concept of mind itself. When you introspect, you'll find that you have the ability to recognize patterns and to care about them, the ability to care about moral value, aesthetic value. And once you do this, it's hard to imagine a mind that lacks those same abilities. Moreover, this fits with our observation of other minds. And notably, the more intelligent a being is, the more it tends to care about moral and aesthetic goods. Okay, so that's the first claim, is just that we might be reasonable in expecting God to have these higher order preferences. The second claim is that those sorts of higher order preferences require worlds with natural regularities. Why? Well, the most familiar examples of moral properties are ones that arise from conscious states of thinking things. And the physical basis of consciousness requires very sophisticated regularities. Moreover, many moral properties, such as properties of justice, supervene on large-scale properties, both synchronic and diachronic, of like big portions of the world. These don't make sense if we have total chaos and utter irregularity. We can make similar remarks about aesthetic properties, which often supervene on coherence, unity, both synchronically and over time, and on the persistence of certain states. Relatedly, the very possibility of aesthetic differences may require a high degree of regularity. So consider first the vast number of possible pixel arrangements that just look like a noisy mess. Like aesthetically, they all appear similar, even if there are dramatic differences. In comparison now, consider the number of pixel arrangements that give rise to interesting aesthetic differences, such as different images of different ordinary objects. There are only so many ways of arranging pixels that results in these. So a high degree of order is always going to be present in the images that have aesthetic differences. A good way of thinking about this is just to think about like what's involved in compressing images. Compression is always only attainable when there's a certain degree of regularity or order, and a noisy mess is never going to be compressible. And finally, God's preferences might, for all we know, be directed towards general features of worlds, rather than just looking at Humean mosaics point by point. But if you start looking at God's preferences for general features, again, this seems to require regularities. So when we take these two premises together, they suggest that God would indeed have preferences for regular worlds. Or a bit more modestly, they suggest that we should be much more confident that God would give rise to regularities than that a pure, mindless, chancy process would. Thus, we think that divine voluntarism appears to have the right kind of internal metaphysical structure to explain why our world exhibits the kinds of laws that it does. Now, at this point in our paper, Tom and I consider a bunch of different objections. We say a lot more about the prior probability of divine voluntarism, but I'm going to skip all of that, because what I'd like to do instead now is talk about some practical lessons that we can take from a nomological argument. And I think that some of these lessons survive even if we don't think that the argument succeeds at the end of the day. We just need part of it to be plausible. So I'll say more about that in a sec. So first, a historical reminder. The modern concept of a law of nature arose in a theistic theoretical framework. So for example, Descartes, after attacking like the old Aristotelian scholastic metaphysical approaches, or metaphysical bases for the natural sciences, provides a mechanistic natural philosophy in its place. So when he did this, he purged his metaphysics of all of these robust and explanatorily powerful natural kind essences and things like that. And in its place, he had very simple mechanical objects. So objects with a state of, with properties like size, shape, and state of motion, and then laws governing their interactions. Descartes also provided and developed some mathematical tools that allow us to model these. So notably, he invented the X and Y coordinate system, which allows us to take all of the tools of algebra and apply it to geometry. So he created analytic geometry, and this allows for like modeling tools that allow us to very precisely represent, measure, calculate the behavior of objects in these physical systems. So together then, Descartes is providing a metaphysical picture of the natural world, one that is governed by God, along with the tools required to actually formally represent this and carry it out with a degree of precision that hadn't been possible under older approaches to science. Others, especially Isaac Newton, embraced these kinds of advances and improved upon them. And for these thinkers, philosophy, theology, and natural science were all deeply intertwined and mutually supporting parts of this big, consistent theoretical framework. So I think it's useful to keep this historical context in mind when we think about the argument that I just summarized for divine voluntarism. I may come back to that in a moment. Here are two key observations, I think. So the first is that, like, in the context of this environment, where you think of these three approaches to, human thought as being intertwined, there is a suggestion that natural science provides insight into the will of God. This is a very important result for theology. It also suggests that scientific methods are reliable methods of learning about nature, which is an important result for the philosophy of science. So in particular, like, there's this big debate in the philosophy of science about whether science is this merely useful sort of practical enterprise, or whether it's an epistemically successful enterprise that points us in the direction of the truth. Realism about science says that it's the latter. Science guides us towards the truth. Now, why might something like divine voluntarism be relevant to this debate? Well, one reason is that God's standards for choosing laws in this kind of framework, based on their beauty or their elegance or their ability to realize properties that we care about, these seem to align with some of the theoretical virtues used in the actual practice of science itself. So in physics, one often finds physicists saying, like, this is a good theory because it's very elegant, because it's beautiful. An instrumentalist, somebody who's not a scientific realist, might just think that that reflects a fact about us. But a divine voluntarist will probably think that it does more than that. Okay, so what sorts of practical applications might we take away from this? Well, for starters, I think that there are some important lessons for non-religious people. So one of them is that theistic religion is not inherently anti-science. It's not opposed to science. Rather, theistic religion can provide a systematic worldview that supports and explains the successes of the natural sciences, and thereby even encourages this very positive attitude towards science. The model of natural theology is one in which, part of how we learn about God and can worship God and come to appreciate the power and the awe and the majesty of God is by learning about creation. And so I think that at its best, theistic religion can encourage an extraordinary respect and admiration for the sciences. As a corollary, I think that there's this very simple sort of takeaway, like for non-religious people who might wish to encourage positive attitudes towards the sciences. It seems easier, at least to me, to convince a religious person to replace hostility to science with a positive attitude towards science while retaining their religious beliefs than it does to replace religious beliefs with a positive attitude towards science. If you can show them that the system of beliefs they already have, that's near and dear to their heart, should encourage them to have a good attitude towards science, that's probably going to be the way to go. What about lessons for theists, people who believe in God? Well, one is this: if you're already a theist and you're searching for a theory of lawhood, or for an answer to the question, why is nature the sort of place that exhibits these regularities conducive to modern science, you should probably be a divine voluntarist. If you've already committed to belief in God, this theory then allows you to provide a satisfying explanation of this remarkable feature of our world, and you don't have to do you don't necessarily have to get into the weeds of these other difficult metaphysical disputes. But more importantly, I do think that when we think about what sorts of reasons God might have had for creating a world like ours, we can see that nature is a direct reflection of God's will. So to reiterate a point I've made a couple of times now, doing science is a way of learning about God's will for nature. And if that's how you view things, you should love, respect, and admire the natural sciences. Finally, I think that theists should have similar attitudes towards the methods that make science possible, namely scientists' use of reason, experience, and so on, and a general willingness to change their mind, adjust their views in response to new evidence and things like this. So at the risk of making a large leap, I think this suggests that reason ought to be integrated into faith in a certain kind of way. I'll spare you some details of this, but I think that thinking about God as creating a world in which science is possible, and then giving us the ability to do science and learn about nature through reason, tells us something important about God's will for us. Okay, I'll wrap things up at this point. If you want to look at the nitty-gritty details of this type of argument for the existence of God, Tom Metcalf and I have this journal article that came out year and a half ago. If you want just like a user-friendly, non-technical overview, there's also a link to a page here. That's all I have. Thank you very much.